All right, so today we're going to go over index fossils. So it's like a next step or the next step for after rock layers. So, all right, here's a question for you. How do we match up rock layers all around the Earth with each other? Because we saw like you could have like little chunks. How do we match them up? How do we know what times happened when? Well, to begin that, to answer it, because there's a lot of things that are involved with it, you need to figure out how old each rock layer is. Okay, so if we find out how old these rock layers are, we can find out matching ones across the world. And to do this, to start, you need to start with an index fossil, something called an index fossil. And this is a fossil in general is the remains of a creature that lived a long time ago. So usually it'll be like skeletal remains, like bones, or say an imprint in a rock or of a plant or an animal. So if you've ever been to the shore and you've picked up a rock and it had like what looked like an old shell in it, that's an imprint, that's a fossil. So with the possibility of dozens or hundreds of fossils in each rock layer that you're looking at, because like think of it right now. If we had a rock that could represent everything that's going on now, we've got lots of plants. We've got lots of different varieties of animals. If someone were to look at it, it'd be kind of confusing. You couldn't figure out this time period from, pardon me, say 500,000 years ago. To figure this out, what you would need to look for is one specific fossil called an index fossil. Now, what the heck is an index fossil? Fossil is just like creatures or imprints of plants and animals that were there. Well, index fossils, sorry, I'm moving my face over there. The first thing required for an index fossil or a fossil, the index fossils, is it needs to spread out over the whole world. So it lives in a large area. So index fossils live in a large area. The second thing is it needed to exist for a short period of time. Geological time, not necessarily time for like you and I, like 10 years might be considered a short time in the span of a lifetime. Oh, sorry. So if you see multiple layers in a rock, that fossil, this one fossil will only be in one layer. So an index fossil, if you see multiple layers, that index fossil will only be in one of those layers. So let's look at this diagram right next to my face. You have a bunch of different fossils. You've got trilobites, birds, ammonites, fish, shell, dinosaurs, mammal. And it shows you extrusive lava and intrusive right here. All right, so just looking at these, we can see if we can like start crossing things out. Like look at this, a trilobite's right here. Ooh, maybe a trilobite could be one. Do I see a trilobite in any of the other layers? No. So yes, the trilobite could be one. Well, let's look at this type of shell right here, the ammonite. It's in two different layers. This is one layer. This is a second layer. And that layer right there matches up to that. So if it's in more than one layer, no, it can't. So I would cross out an ammonite. Let's look at the fish. Well, the fish is only in this layer on this side, and only on this layer on this side. And these two layers match up because look at this. That layer matches with that. So I can conclude that a fish could, a fish could also be a index fossil. What about this thing right here? That's a shell. I only see one shell on this, one shell on this, and again, they match up. So a shell could also be an index fossil. Well, let's look at this thing right here. This is a plant. Sorry, the plant's up there. I missed that one. So there's a plant in this one and a plant in that one. That automatically cuts it out. So if it's in more than one, you can like cross it out. It's no good. Dinosaur in more than one. So I would cross out dinosaur. Feather or a bird in more than one. So I'd cross that out. But look at this. All at the top, you see the mammal. So definitely a mammal could be in. So we have trilobite, fish, shell, and mammal. They could all be used as index fossils. But there's another index fossil that is not a fossil, but volcanic ash. Well, why would volcanic ash be an index fossil or a good indicator of time frame like an index fossil? Well, this is because volcanic explosions typically last a short while. They don't, geologically speaking, they don't last for millions and millions of years. They're just kind of like a quick thing. But when a volcanic eruption does happen, a very big one, ash covers the whole entire earth. So that's a good, it layers the whole earth. So it's a good indicator of time. All right. So if we look carefully right here at this diagram, which letter fossil would make the best index fossil found over a large area? That means all four layers, but good for a short period of time. One section in each layer, like one rock layer in each layer. So again, I'm going to go through and I'm going to try and cross things out. So first thing, I'm looking at B, this trilobite. Well, I can already see it's in two sections, so it's automatically crossed out. B is out. Let's look at C, because C is right there. Well, I've got a C here. Ooh, that looks promising. But look, I look over here and it's on all four sections. So I'm going to cross out C. Let's go next. We've got this A. Let's see, it's only in one. Good. Only in one. Good. Only in one. Good. Only in one. Great. Well, A's looking pretty promising. Well, let's look at D. Has the spiral thing. No spiral thing, no spiral thing, no spiral thing, only one spiral thing. So it's not good. It would have to be in all four outcroppings for it to be considered an index fossil. So my index fossil is letter A. I'm going to go a step further with this. So if that fossil, say, is Manticosaurus, you can then label the rock layer with geological periods. So we know that A is the M word, the Manticosaurus. So if I know it's a Manticosaurus, well, what do you need for this class? Every single period, every day, you need your reference table. It's the tool you need to pass the regions, the tool you need to pass this class. All right, so what I would need to do, if I was to look down here, I would find the Manticosaurus as letter G, right there. So what I would need is to look across from here, go all the way over to this section, and find the G. And the G is right there. So what I'm going to do is I'm going to follow it right back to right there, and it is labeled as Devonian. So I know the rock section 3 is Devonian. All right, so if I know that, rock 4 is on top. So if it's on top, here's Devonian. What's above it? Carboniferous. So I'm going to label 4 as Carboniferous. Well, what about rock layer 2? Rock layer 2 is going to be what comes before Devonian, which would be Silurian. And what comes before Silurian? Ordovician. And that's how you label them, which will help you in your next section for your activity. If you have questions on it, please hop on Zoom. Let me know you have questions. I'll walk through it with you if you need it. Tomorrow's the last day. I'm reminding you, last day to submit work for the quarter. If you have questions, get a hold of me, email me, and I'll talk to you guys later. Bye.